I have a few slides, as Matthias said. But yeah, I will jump back and forth into real demos because yeah, I guess you're all suffering from PowerPoint overload at some point, right? So I thought I'd start by doing a introduction to Hop, what it is, and then dive into how can you run Beam on top of Hop, basically, right? And then we'll go into a pipeline which generates synthetic data on Google Cloud Dataflow. And then we'll see also a pipeline running in parallel then, which takes that data and processes it and streams it into Neo4j graph database. And then we'll see how that graph populates itself. And then I'll talk a little bit. I think I should be running out of time by then, but a little bit of time to say, okay, how can we also orchestrate work and lift this solution to a higher level? All right, so let's dive straight into it. So HOP is not based on a beer component, but it's simply a recursive acronym. The HOP orchestration platform was mainly designed to be short and impossible to misspell. So we're doing data orchestration, which means that for data we run not just pipelines, but also workflow pipelines, parallel data processing machines, workflows, uh, step-by-step logic, serial sequential execution, and evaluation of results, stuff like that. Metadata is quite important to Hop. The editing, the handling, the management, configuration management, all these things, projects, that's quite important to Hop. Also providing insight, data execution, logging, all these kind of things. And then handling ecosystem complexity. These are all things that we want to do. Uh, why do we have Hop coming about? Well, we need to do a better job of orchestrating data. We need to have an easy solution, and easy in setup, build, maintenance, deployment. It's easy is such a wide and important topic. Fast also means not just running fast with engines like Spark, Flink, Dataflow, but also fast startup time and fast to market. When a new engine pops up, we want to be there. When new technology pops up, we want to be there. And obviously, this is why Beam is important to our project. We want to be transparent before, during, after execution. See what's going on. Uh, and predictable unit testing, integration testing. These are things that we want to provide for the integrations, the data orchestration solution. And obviously, we want to play in the digital transformation space, so we need the latest technology. Um, you know, Hop originally came from the Kettle world. Kettle was a project from which I was the founder originally, and it's become a bit stale. It's been 4 or 5 years since we had a major change in the software. And from the community, there was a desire to improve things, a desire to evolve with the rest of the world. And without the community, Hub would not exist. So thank you to everybody involved. And so it's coming from a collection of, let's say, kettle-related code, a certain version, 8.2, something that we picked, plus bug fixes, plus a whole series of plugins, plus a different branch for the web part. It all got merged together into Hop, together with a whole bunch of refactorings. And so community members have been doing development, website, Git, Jenkins, our Mattermost, which is the Slack clone, the open source Slack server. But we got artwork, documentation, donated videos, and the Apache Software Foundation has been somewhat involved as well because we want to make Hop, we want to incubate Hop. So we have our incubation proposal about ready. So next week or something, we will fire that off. So we're still in need of a few extra mentors. So if you're into that sort of thing, just contact us, please. Architecturally, uh, we have a bunch of reusable Java libraries. Core engine and GUI, and core handles data types, logging, rows, metadata, passwords, encoding, that sort of stuff. And the engines contain a lot of stuff related to the actual work. Uh, that being said, their kernels, we split off anything that is not a reusable part and not off splittable, let's put it like that, right? So these are all kernels relying on plugins for most, if not all, functionality, which makes it easy to add or remove functionality. And we can now make very small releases suitable for lambdas or very small microservices, or big releases with everything in the kitchen sink in it. The software architecture of Hop is very similar to a Beam pipeline in the sense that you have the pipeline, the hop metadata, but it works for both pipelines and workflows. And then we execute it using certain configurations on a certain engine, or in Beam terminology, the runner. We can have the classical hop local engine, which is a simple multi-threaded engine. We can execute it remotely, but also on Beam Spark Fling data flow. How do I get my hands on it? If you want to play with it, you can go to projecthub.org, you download it, and you get the latest snapshot. Because we've been in feature freeze mode for the past couple of months, so that way you get the latest bug fixes. All right, how do you install it? There's a video on the website, but basically you install OpenGDK version 8 and you unzip. And the documentation is also available on projecthub.org. And there we have a wonderful getting started section that you can use. Let me do a quick walkthrough. We spent some minutes on that. Uh, so if you unzip that that project, let me just kill hop. So then you have a bunch of shell scripts. Most of them are self-explanatory, but let me just go through them anyway. So hopconf is used for configuration of various aspects. You can set specific environment variables for the hop runtime. You can create projects with it. You can do all sorts of stuff with it. It's a pluggable configuration system, so features that add things, plugins to Hop, can also add configuration parameters on the command line. And obviously, this is important when we're building automated software stacks or using Docker container building, stuff like that, right? Hop encrypt is used to encrypt sensitive data. Obfuscation or encryption if you have the plugins for it installed. The Hop GUI runs the GUI locally. Hop run simply runs a pipeline or a workflow from the command line. Just run the file. Hop server starts a server, and Hop translator is a tool for I-18N internationalization efforts. So if you want to translate Hop into your favorite language, then you can use that tool to translate Hop. Configuration wise, there is a config folder, and it contains a simple config file, which basically says there's one project here in the standard download, which is called Beam Demo, and uh, it contains some Beam demonstration files. Audit basically says, okay, there is some auditing information from Beam Demo, and basically opens a sample when the Hop GUI starts. I'm not using any of these two folders right now because I pointed it somewhere else, because as you can see, I'm running straight off of the latest assembly. Um, there's also a way to start the Hop GUI as a Docker container. Let me just do that just for coolness sake. And so the Hop GUI basically runs on localhost 8080 Hop UI. And as you can see, it only takes a few seconds to start up. So this is thanks to massive optimizations and refactorings that we've done. It can run in your browser, basically, right? All right. So this is based off of the web branch, and we're merging that together as soon as we can. Branch. So if you go to the Project Hop website, let me just point you quickly to where the goodies are. There's a link to the Hop GitHub project, and there you can see the Hop code, the Hop documentation efforts, the website, and the Hopper Docker container project that aims to provide a standard documented Docker container for Hop. All right. Up here you have the link to the Mattermost server, Twitter, LinkedIn, YouTube videos, all that sort of good stuff. All right. So now let's start the GUI. I think it looks a little bit better. Full client. All right. So once that gets started, let's go through a quick overview of what we see here. Uh, so we split up our workloads, basically our various projects, into official hub projects. And so I created a project for the Beam Summit. And once you have a project, you can also do lifecycle environment management. You can say, well, I have a project, Beam Summit, in development, production, test, whatever, right? And so you can create various environments for that. For this thing, I haven't done that. And so this is the main toolbar. On the left-hand side, we see that we have a data orchestration perspective, which we have now. We also provided search capabilities for either the current loaded object in the Hop GUI or the whole project. So it searches through all the files in your project for a certain string, and it shows you the results. We have another perspective for our own purposes to see, okay, did my transform plugin load it or not? And then finally we have a Git plugin with which you can actually do commits and staging and staging out staging and that sort of stuff without having to drop to the command line to do that. All right, we go a little bit further then. Uh, in the GUI, you can see that um, if you do new, a lot of this is driven automatically from a plugin perspective. So as you can see, I added a non-hop plugin for Neo4j connections and graph models and stuff like that. They pop up as native capabilities, right? So if I create like a new pipeline, I get a new pipeline. It's all seamlessly integrated, which makes the GUI less cluttered than what we had before. Shared metadata management is simply done through a simple browser. Here we see all the samples I prepared. So save, load. You can easily switch back and forth. And important to note is that your usage date, your usage, the zoom factors and everything is stored in that audit folder I showed you earlier, so that you have a stable experience. If you shut this down and start it back up, you get the same kind of like the same view that you left off with. All right. I see that always almost 15 minutes are gone, so let's let's continue, right? Um, uh, where's my presentation? All right. So the first thing I wanted to show you is based off of this standard Hop GUI. How can we build Beam run configurations? How can we set the pipeline properties for, in this case, the data flow runner? And let me just jump straight into it. As you know, like the easiest way to run a lot of Beam is to start from a fat jar, jar, which basically a single file which basically contains all the software, the whole configuration that we have on our hands. And for this purpose, the Beam plugin basically exposes a new menu here, allowing you to generate this hub fat jar, and it will then drop onto some folder that you have. This makes it easy to not just run on Dataflow, but also on Spark and Flink, because they heavily rely on having a single jar file, right? The second thing that we need to do is, if we look at our run configuration for the pipelines, we need to create one for Dataflow in this case. In this case, I'm saying like, okay, my engine, I have a bunch of them: uh, Beam Dataflow, Beam Direct, Pipeline, Flink, Spark, and then a local one and a hub remote one. Right. So I can basically look at the API from the Dataflow pipeline options, and then you will see that the tooltip pop-ups are the same as the Java doc, basically, right? Um, and so this makes it easy to say, okay, I want to run on US East 1, use a standard small worker machine. And this is the fat jar that I generated for hop 0.40. Okay, so now we can just run this and specify that data flow pipeline run configuration. And if all is going well, it will show in the logging that it has built a new Beam pipeline. And then we can simply jump to the data flow jobs here. As you can see, I've been testing a bit, as you do for a presentation. The first thing that you will see is that normally this process takes quite a while, because it needs to upload 300 something megabytes of libraries into uh, Google Storage. But since I've already done that for obvious reasons, uh, we see that the pipeline is starting immediately, right? And while it takes a while to start, let me just show you what we're doing here. Uh, this icon basically represents a transform. And what is this transform doing? The name generate rows means it's generating static rows of data. In this case, infinite, never stop generating rows. And it's using an unbounded synthetic data. I'll dive into the code in a second. Um, this transform runs the same whether or not you're running this locally or with any of the Beam engines. And secondly, I'm generating some random data, random integer UUID, to calculate some user ID out of 10,000 users. And I'm also generating some fake Pokemon data. And finally, I'm assembling a JSON message based off of that. Let's see what's going on here. It's still running. And yeah, so let's take a look at how we convert this piece of metadata, which is essentially just an XML file, into actually the synthetic variant of this. If this is too small, I apologize. If you have any questions about specifically these things, I will jump on the Apache uh, Slack channel after this session. So the metadata from the row generator here is getting loaded off of XML, and what we're seeing there is, okay, if this thing is never ending, then we have a synthetic unbounded source, which is part of the Beam API, one of the many sources. And if not, it's going to be a bounded synthetic source, right? So we have a whole architecture where a lot of the native, let's call it older um, hop transforms, the metadata gets translated uh, into proper Beam code, applying it to the correct P collections, etc., etc. The point is, you don't really have to worry about this. In the meantime, we see that the pipeline has started on data flow. Let's take a quick look. We've added all sorts of metrics to the various steps. We specified like a 10 millisecond delay between the various rows on average, that which translates to something like 100 rows a second, something about along those lines, right? And what we're doing is we're generating fake data, and we've incorporated during my vacation. I incorporated a cool library which I think is called JFake, and it allows you to generate Chuck Norris quotes or colors or addresses or names of Harry Potter characters and stuff like that. In this case, I chose to generate Pokemon names and locations. And the idea is that you have some app that you want to simulate, and the app is a user which detects a Pokemon in a certain location at a certain given time. And from that, we encapsulate that into a JSON and send it off to a Kafka server, as you do, to mix and match a little bit of the technology. And so the next thing that we want to do, um, if we go back to where we are, so the next thing we want to do is stream that data, read that data back out of that Kafka stream, and we want to read the data, parse the JSON message back again, enrich the data with some Pokemon dictionary information. I want to know what type it is, and write the data into a small graph. Because obviously time doesn't permit us to expand this much further. Let's see how much time I have left. Yeah, that's fine. So let's take a look at that. So there are two ways of looking at this thing. And the first way is like, okay, we can read that data from Kafka. We have a special Beam Kafka consume transform for that. And there's like a simple topic, and you know, simple enough. We parse the JSON again. You specify the field expressions of how that is encoded, and then you can have that reference data. In this case, I stored it on S3 in AWS on a totally different technology than Dataflow, right? So that's a problem because this is not a specific beam transform. So how would that have to be done? Well, if we go to the transform that I ran earlier, this one, you can see that it's actually trying to, it generates one value. This is what you need to do in the Beam API to make sure that that file only gets read once and absolutely only once. It creates one value, just a dummy value. It does a group by, and it flattens and iterates it, forcing the API to just execute that. Even though it says parallel to it, just executes this thing once. And then it loads that, site loads that data into the lookup transform. And the Kafka stream then is combined, and this is how this is streamed through. The one that we're going to use now is the more trivial way of doing things, is simply running the data off of a file on Google Storage. How do we do that? Well, I define this file definition, the layout, if you will, of that file in a way that says, okay, I have a field separator and these are the file fields. Uh, and, I can run this locally actually with a local engine and actually preview the data, because that's one of the problems if you're developing against these things is, okay, so now I need to connect to that data, but I don't want this to be ever changing. I don't want to rely on the fact that the Kafka queue even exists, right? So I just prefer to have 100 random messages. So Pokemon messages. Here are the ones that I have generated off of the output of the other transform. And so what you then have is something that you can test and develop with locally. And since we generated the fat jar off of the same code base that we have here for these transforms, we're certain that the same code is going to run on Dataflow as it is going to run locally. So now we can have unit tests also created with golden data testing. I will show maybe an example in a bit if I have time left. But this is a different way of ease of development, right? So with this kind of system, you can develop these things in a matter of minutes. So let's run this thing on Dataflow, and in the meantime, let's see how that other stream is doing. Here you go. Yeah. So as you can see, this starts up pretty quickly. And so it's in this case it's starting up the cluster, but you can see that the graph the chart is simple, right? You just side loading a few hundred records of Pokemon data and then combining it with the Kafka stream is much easier than doing it otherwise. All right, let's take a look at. So what are we doing here? So based off of a simple Docker container in my sandbox, which contains Neo4j, um, I am going to run some cipher, which basically says like, I'm going to create detections if they're not there yet. I'm going to merge, create or update a user, Pokemon information, locations, and I'm going to create a small graph out of that. I'm going to show you later on how that works. And now you can start to wonder, like, okay, so but this connection information, right? How does that end up on Google Cloud in the storage? Well, this metadata that we have here all gets serialized and encoded and sent with the rest off into the cloud, so that every node, every transform, every function knows exactly what kind of metadata it is, so that the native steps when the code runs, it has access to the exact same information that you have here on your workstation or in your browser in a Docker container. That's how that works. This also means that there's no more shared metadata anywhere being kept around. There's no more synchronization efforts or whatever that you need to do. And it also means that with the fat jar approach, that you can have multiple versions of hop running in parallel at the same time, all people with different metadata, and it wouldn't matter, right? Whether or not it's on Spark, Flink, or Dataflow, you can just do this in parallel. Okay, I see that this thing has started to run as well. Um, okay, so these things are chugging along. You can see with the metrics that we're leaving that 800 records have been read from that Pokemon CSV file, and let's see if we can find Mr. Pikachu or Rattata. There's another Pokemon and so we have one detection for Mr. Rattata. This is how this is expressed in the Neo4j graph, and that detection is also linked to the user and the location, Little Root Town. And maybe there are other detections that happen in that location, and yes, there are other Pokemons. And so this is how you can explore that graph and ultimately run all sorts of algorithms on this, clustering algorithms, shortest path, and it's very interesting to see how quickly you can You can build complex graphs that actually really provide a lot of value. Now, why am I focusing on Google Cloud Platform? Because obviously Neo4j is championing Aura. It's cloud-based, fully managed Neo4j database. Automatic backups. You don't have to worry about anything. All you need is a credit card. I'm told, right? All right. Uh, I see that I'm down to my last 10 minutes. So yeah, if you go to the Beam demo project, it's also pretty cool in the sense that we have a bunch of uh, test cases in here, which basically show off the versatility of the various components, not just the beam steps, but also merge, join, grouping, side loading with the stream lookup, and targeting individual transforms with things like switch case, where you say all the data from California goes to a specific target transform, where you can handle the specific case for those pieces, those sets of records, basically. There's other things that you can do, like windowing data. Uh, in fact, if you simply look for Beam in the pop-up, uh, if you look for transforms to, you will see that okay, we have support for BigQuery, Google PubSub, Kafka, and timestamp handling. So you can say, okay, I'm going to get the timestamp from my Kafka message, or I'm going to apply a timestamp to a bounded data stream, for example, a bounded collection of data. All right. So make sure to give those simple examples and more complex examples a glance. Uh, yeah, let's start to wrap up. Uh, because if I start another topic right now, it's gonna go a little bit of out of bound. Uh, so yeah, orchestrating work. For now we've only looked at pipelines, but obviously it's also important that we orchestrate this a little bit. And the pipelines typically have a start place, and the idea is that, well, now I want to, for example, first typically ping a server, right? See if my server is up and running before I'm trying to get data from it. And then you typically add another, maybe if I'm dealing with Neo4j, I want to say, well, let me just check if the server is up and running before I even start to run anything off of it on it. Before I even try to run and load data, why I'm be a little bit defensive, and then I load my pipeline, then I can execute a pipeline. And if anything goes wrong, you can say, okay, I can send off a mail to the operators, for example, in case anything goes wrong. And this is the error. And so every time that you have one of these hops, as we call them, links between two actions, um, we can set them as unconditional, true or false, basically. Right? All right. So this is essentially the basics. The only engine we have right now is a simple backtracking engine, but we are investigating whether or not we can actually generate code for, let's say, Apache Airflow, or provide alternative workflow engines in a similar way that we're doing with the pipeline engines. All right. For my last 5 minutes, I'm going to slowly wrap up and see if there are any questions. So yeah, consider Hop for your Beam projects, not because it's easier than writing them in Python or in Java, because we deliver a whole wide world around it, from project to configuration management, search, and integration with Git and all these kind of things. And my pet favorite unit testing, so that you can basically make sure that I have a simple set of tests which allow me to test locally before I'm going to run this off against a gazillion records. As we've proven in the last couple of, last year, we welcome feedback and we thrive on feedback. The fact that the new GUI that we wrote is so smooth in such a short amount of time is based on tremendous amounts of feedback from a lot of people. So I want to thank you and everyone involved in Hop for that invaluable gift. And thank you. Join Project Hop. And let's see if there are any questions, Matthias.
Thank you very much for sharing, Matt. Yeah, I think it will make a lot of people's life easier and speed up pipeline development. So, yeah, nice.
Hmm.
I particularly liked how it facilitates testing fake data sources. So that's something I'll
Yeah,
probably.
yeah, yeah. Yeah, I can show you, for example, in the Beam demo. Uh, no, that's fine. This is for example a unit test. So the golden data here, represented in the data set, gets actually matched if you run this locally. So not only can you see all the various sets of data that are passing through the individual transforms, but it's actually get tested against a golden data set. So what you can then do is say, okay, I have a test case here which runs against, let's say, 10,000 rows, or let's say 100,000 rows. It runs locally against the unit test. Then I'm going to run it against, let's say, a Flink engine, see if that works. I can sniff test the output against a couple of million records. And then you run it on the big engines, your Flink, Dataflow, or Spark engine, before it starts to cost a lot of money, before you start to run a trillion records against this thing that you invented. And I think that makes a lot of sense. Also, for protecting the investment, the time that you put in here, I think that's really important.
Yeah,
Great.
definitely. There is one question from the audience so far. Start with love your presentation and Hop. Is there a plan to add more sources and sinks like Bigtable, Spanner, Google Cloud Storage, etc.?
So we do have we already support Bigtable, but yeah, we do plan to add more and more of the Apache Beam IOs in such a way that, right now we have a transform for the old Hop engine and one for Beam, and obviously that's not a good idea to keep it like that. So there's a merger taking place so that the metadata is the same regardless of the underlying engine. There's still some cleanup, but that's going in the right direction. It's very very easy to add new YOs. I tried to show it quickly, but it's just a matter of metadata translation into the Beam API, basically, right? Very simple, very straightforward. You can do a few of these in a week if you're slow, right? Uh, Most of it. So for Google Cloud Storage, though, so we're also using another Apache project, which is called Apache Virtual File System, Apache VFS. And so the reading of, for example, the AWS file uh, in here. So this reads directly from S3. So this basically uses environment variables to resolve my credentials and go straight to AWS, and that makes it easy. So we have in the works the virtual file system driver for S3 is in there, for Azure, for Google Cloud Storage, and the one that we already have is for Google Drive, because sometimes people store sheets on Google Drive or whatever kind of documents. So you can already get those from inside of Hop. But yeah, it just takes a bit. But these are all just implemented as plugins, so we can add more. And we are working also on a sort of marketplace where you can put all these things so that not everybody has to use all the technology and all the libraries and jar files. Before you know it, you have a terabyte to handle when you're running a simple pipeline. That's not the point, right? Yeah, great question. Yeah.
Awesome.
And as before, if there are any people that want to help out, please join us. We always have a few Jira tickets that are easy to implement, so that you can get started with the code base. Myself and the other developers, we're more than happy to help you out if you wanna get started with this. So so jump on board.